Hello everyone, this is Shivam Agarwal. We are back with another video. This video is all about abstraction. We have finally moved towards our last steps in this module, where I will tell you about all the four pillars of object-oriented programming that I mentioned in the first video, that are abstraction, encapsulation, polymorphism, and inheritance. Today we'll study about the abstraction, right? So let's see what it is. As I've already told you, abstraction is hiding up of unnecessary data from the end user. Okay, suppose we have to create some methods or variables that are not to be accessed by every user but are to be accessed by developers or maintainers of the program. Then we can create abstract classes and abstract methods to implement this concept of abstraction. Okay, to hide up or take the classes or functions away from the user so that they don't have to deal with the complexity of declaration of those. Okay, so we'll see what abstraction is used for and how to do it. So abstraction is basically used in daily life, where there might be a third-party application that is supplying some functionality to you. There might be the case that they want to justify that what you have to create. They want to justify the question that what you want to create. They might not give the definition for every function, but they want to supply that, yeah, you have to create something called as a function one, and they give the declaration for the same. Okay, so they don't have to deal with the complexity of the whole program that a developer might create. They just want to create an abstract class that will show what they want to create, and the developer can modify it in the later programs in the inherited classes, right? You have studied about the inherited classes. In those classes we can alternately modify the function using our need. Okay, so that is why abstraction is used. To create API calls and other things are some of the examples also. So how to implement it? Python supplies us a module called as ABC to implement abstract classes. Okay, so ABC stands for abstract class, and there is a method called as abstract method for making a method abstract. What is an abstract method? A method that does not have a definition, just we have a declaration for that method, is called an abstract method. An abstract class, any class that has an abstract method which does not have a definition, is called as an abstract class, right? You understood that? Let's move on declaration and description of this. So for creating abstract class, we'll have to import the module ABC. I will say from ABC import two classes. I will import abstract class and I will import abstract method. These are predefined all. Okay, so let's try to create a class, abstract class. I will say that, yeah, I will use class of any number of sides of a polygon. Okay, so I'll say that, yeah, polygon is anything which is a closed loop and has sides greater than or equal to 3, right? It's called a polygon. So I'll say we have a class called as polygon. It is an abstract class, so it has to be inherited from abstract class ABC. That is how we declare an abstract class. Okay, this is the declaration of an abstract class. So polygon is now an abstract class. It should have an abstract method. So how to define an abstract method? We have to decorate this class with an abstract method. How to decorate? We already know, using the @operator. Using @ we'll decorate it. Abstract method. That is the suggestion. You can already see I'm using PyCharm IDE for such suggestions. This is the abstract method decoration. Now we'll define any function called as sides. Let's say sides. Okay, and I'll say just a self function. It is already defined. Okay, so as I have already told you, the abstract method won't have anything. So the function in Python that has anything, that has nothing, has pass. Okay, so in this I will write just pass. So this is an abstract method called as sides, and this is an abstract class called as polygon. Okay, how we will use this sides and how we will use this polygon is the next. Okay, so now I have to create some more classes to use this polygon and its abstract method. I will inherit a class called as triangle using this polygon, and I will override its abstract method. How to override this? Just use def and use sides. We have to use self here also, and as it has 3 sides, I'll say just print 3 sides, right? This is how I override the abstract method. So you can see, as I created the abstract class, I did not define the sides function here, but as I have a class called as triangle, I know how many sides it has. I can define this sides and override it using 3 sides. Okay, so I have a definition over here and a declaration over here. These are two different things. Again, if I want to say that, yeah, I have a class some square, and I'll say it is also a polygon. What I can say, it has 4 sides, so I can override a method def sides, again self, and I will override it using print. It has 4 sides, right? So I have overridden multiple times. The single declaration of sides function is being utilized more than one times over here. In the class triangle, it is overridden. In the class square, it is overridden. You can override it multiple times using pentagon, hexagon, and so on. But I will stop it right there. What I will do, I will try to call this sides function using the objects of both the class. I'll create an object called as T for triangle class. I have nothing to do. Yes, it will call the sides function using t dot sides. So let us see what is t dot sides. Before this, I will create another object for square class, and using this a different object, I'll call the same function, and I'll see whether these are two different things or not. So to implement abstraction, I have done an import. Then I have created an abstract class by using inherited class using abstract class. I have created an abstract method of sides, and I have overridden it twice. Let's see what happens if I execute it. It is printing 3 sides and 4 sides because first the triangle is executing and then the square. So it's working quite fine. If we want to hide this abstract function over here, abstract class over here, polygon, if it is not available in our directory, if it is being pulled from another module, what the user will see, the user will only see this triangle and square, and they will be able to use this sides function multiple times according to their requirements, right? So that is how we implement abstraction. I have another way to implement it. If we don't supply it over here, if I just remove this decorator, what will happen? It is still a function which has no definition, and polygon is still an abstract class. Okay, so in the next class, if we see, we have overridden the method, right? What will happen if I now execute it? It's still giving me the same output. So what we have concluded, that yeah, any function inside an abstract class can be either abstract or it can have a definition also. If it is an abstract function, it in a standard way, it should start with the decorator. If it is having any definition, it can have a definition also, right? So we can create this type of abstraction using these two methods. Okay, yeah, so that will be it for abstraction. We'll study encapsulation next. See you there. Thank you.